This is Mr. Precella, and today in college algebra we're going to be solving quadratic equations. And you may recall doing this in a previous previous algebra class, at least some of it. And let's first of all define what we mean by a quadratic equation. I'm defining quadratic, not equation. An equation is a statement that has an equal sign. Okay, a quadratic equation can be written in the form ax squared plus bx plus c equals 0. The important thing is there must be an x squared term in order for the equation to be quadratic. If there weren't an x squared term, that would be a linear equation where you just have an x and the only exponent on it would be the understood 1. There has to be an x squared. So if a, b, and c are denoting numbers, real numbers we could say, or any sort of number, we better make the statement that a can't be 0, because if it were 0, then it wouldn't be quadratic, it'd be linear. We're going to see several ways of solving quadratic equations, and the first method that we're going to discuss is the factoring method. And this is something I'm going to be assuming you've done before. Somewhere along your life, just because you're in college algebra, you've done factoring before. Here at this school, we cover what I'm about to review at the end of Math 371, Elementary Algebra. It's the first of our developmental algebra courses in the sequence. The factoring method might also be referred to as the zero factor method, or it might say use the zero factor property. So, if you're going to do the factoring method, you're first going to have to write the equation in standard form. And standard form is this ax squared plus bx plus c equals 0. You should have a 0 on one side, and then the x squared x constant equals 0. Once you've done that, you'll factor. Now that's the stuff I'm going to assume you've done before, and I'm going to try to review it a little bit, and it'll be popping up off and on all throughout the semester. It's one of the major topics that keeps coming back, okay? Or that you will be using it off and on. So it's going to be important that you remember how to factor and sort of practice with it. And then once you've set the stuff, or once you've factored it, it's going to look like this. You're going to parentheses times parentheses equals 0. I'm going to be factoring with the reverse FOIL property. Once you have it like this, if you have two sets of parentheses being multiplied together to give you 0, there's a property of 0 and multiplication which says if a times b is 0, one of those, either a or b, needs to be 0. So you'll set each factor equal to 0 and solve for x, or whatever the variable is. Before we just jump in and start doing a few of the homework problems, I have a few, let me just review a little bit. What we're going to be doing is the reverse FOIL. That's what we mean by factoring. I'm going to make a little table. To factor something in the form ax squared, then plus or minus bx plus or minus c. Okay, so I'm putting this plus or minus. I'm going to be referring to this as the first sign. It'll either be a plus or a minus there. And this is the second sign. I'm always going to make the assumption that A is a positive number. If you're going to factor something, it'll always factor out easier if that first number is positive. Okay, so first sign, second sign. You're going to be writing out two sets of parentheses and filling in those parentheses if the making a little table factored. Okay, so if, depending on that second sign, factored form, this table is going to help you figure out what goes inside, what sort of sign plus or minus goes inside these parentheses. So if the second sign is plus, then the factored form, this second sign here were a plus, the factored form is going to have 2 of the first sign. So if the second sign is plus, you look at this sign here. Is it going to be 2 pluses or 2 minuses in these parentheses, depending on what that first sign is? And I'll try to justify that statement once we actually have some numbers here. But it basically says, okay, if 2 numbers are going to multiply together to give you a positive number, then you either have to have positive times positive or negative times negative to decide which. Look at this one. Now, if the second sign is a minus, then the factored form has 1 plus and 1 minus. Let me see. I'll put one more column here. That second sign is plus, you're going to add the outer plus the inner to get the middle term. If the second sign is minus, you subtract the outer and inner, and that should give you the middle term. And that might make more sense as I actually start doing an example. So here's an example that we're going to do. Let's suppose we're told to solve this equation. 4x squared minus 23x plus 28 equals 0. Okay. To do that, I usually start off, okay, what numbers multiply together to give me 4? Well, okay, there's 1 times 4 and 2 times 2. And I come over here, ooh-wee, already cutting the lights off. Okay. When that happens, if it goes black for a second, it's not your computer or anything, it's just that the motion sensor in this room is still not detecting enough movement. Okay, numbers that multiply together to give 28. 1 times 28, 2 times 14, and 4 times 7. Notice, I should have mentioned this already, this is already in the standard form. Okay, so when I said write it in standard form, ax squared plus bx plus c equals 0, it's already done like that. Okay, now we need to draw our 2 sets of parentheses, and we're going to have to fill in those parentheses. It's just a trial and error process. Right off, what can we fill in right off? Well, the second sign is plus, so the sign in the parentheses, there should be 2 of the first sign. The second sign is plus, 2 of the first sign, so a negative times negative. Now, a little hint on helping you fill these in, because it's just a trial and error process, but there are some little guidelines you can use. Okay? If you're factoring correctly, there should be no common factor other than 1 inside the parentheses. No common factor other than 1 inside the parentheses. That's a huge statement there. Like right here, I'm just going to give you some examples. If you were factoring and you had something like this, 6x plus 12, you shouldn't have that inside the parentheses, because if you do, what number other than, is there a number other than 1 that divides into both of these? Well, yeah, there's quite a few. 2 divides into both of them, 3 divides into both of them, 6 divides into both of them. Shouldn't be any, you can't have that. Okay, what about this one? 4x minus 9. Well, is there some number other than 1 that divides into both 4 and 9? When I say divides, I mean divides evenly into with no remainder. Well, no, 1's the only number that divides into both of those. So that one would be okay. What about just 2 even numbers in the parentheses? Just any 2 even numbers, like 2x minus 4. Is there some number other than 1 that divides into both of those? Well, yeah, 2. So you shouldn't have 2 even numbers in the parentheses. So I'm about to begin the trial and error process here. So if I started off, let's try 2x times 2x. I think that my no common factor other than 1 rule is about to be violated if we use 2x and 2x. Because like right here, if we tried 4 and 7, we couldn't put the 4 in either of these sets of parentheses. You'd have 2 even numbers. What about 2 and 4? Well, no, you couldn't put that. The 1 and 28, well, the 28 can't go anywhere. The 2x and 2x can't possibly work. Why? Because then you couldn't put 4, 14, 28, or even 2 in any of those. So let's try 1x times 4x. So I'm going to start here, and I'm just going to sort of go, can I pair it in such a way that I get this correct middle term? I'm going to be looking at the outer and the inner. Since that second sign is plus, that outer and inner term should add together to give you that middle term. Okay, so if I try 4 and 7, oh wait, I already know the second sign is plus, so 2 of the first, so there should be a minus and a minus. But the 4 and 7, the 4 cannot go here, because if you put a 4 right here, then there's 2 even numbers. In fact, 2 and 4 both divide into them. So if the 4 can't go there, if I'm going to see if this pair works, let me try the 7 here and the 4 there. Now, we're foiling this stuff out. X times 4x is 4x squared. Negative 7 times negative 4 is a positive 28. What I'm doing right now, these little mark is the outer and the inner. Negative 7 times 4. If you were filling out, this would be a negative 28x for the inner. And x times negative 4, that would be a negative 4x for the outer. Do those add together to give me this middle term? Let's see. Well, look at that. I just made a mistake. I said don't put the 4 here, but I did anyway. But you see, that doesn't work. If it's going to work, there should be no common factor. So let's try it again. I shouldn't have even had to check that one, but I did. Okay, so it's just a trial and error process. So x times 4x, second sign is plus, 2 of the first. The 4 shouldn't be there because there's common factors. Let's try the 4 here and the 7 there. That's what I wanted to do. See, I shouldn't have even, this one here, I just wrote the wrong thing down. I'd already said you can't have the 4 and 4 here because there's common factors. And you can see negative 28 and negative 4 don't combine to give negative 32. So let's see. What about this? If we do outer and inner. Negative 4 times 4x, that's a negative 16x. X times negative 7, a negative 7x. So this is a negative 23x. Yeah. Notice, a negative plus a negative gives a negative. That's why I'm saying the second sign is positive. Then that means you need 2 of the same sign here. You need a positive times a positive, or else a negative times a negative. The way you decide is looking here, you want these numbers to add together to give a negative, so they're going to both have to be negative. If you had put plus here and here, then the middle terms wouldn't be negative 23. They'd be positive. So once you are confident that you have this thing factored correctly, you set each factor to 0, and you have 2 linear equations. How do you solve this? Well, to get the x by itself, you perform the opposite operation to both sides, beginning with addition and subtraction. So I'm adding 4 to both sides. So 4 is one answer. Move the 7 over. Oops, by moving the 7 over, I mean add 7 to both sides. Divide both sides by 4. So 7 over 4 would be the other answer. Now, let's do another one of those. Keep in mind, you shouldn't have common factors in the parentheses. In a moment, we'll do some from the homework. Let's see. Here's the one we're going to do now. Let me move this down a little. Okay, so we're going to solve 2x squared plus x equals 10. Well, first of all, this thing isn't in standard form. I'm going to need to move that 10 over. And the way I do that is by subtracting 10. I'm not sure how your previous teachers have done it. My habit is to put the little arrow, which means subtract 10, subtract 10. So here's the equation. 2x squared plus x minus 10 equals 0. You've got to have that 0 on one side before you start doing the factoring. Now, the second sign here is a minus, so there's going to be 1 plus and 1 minus. So I'm just going to wait to fill the signs in. Let me go ahead and write out numbers that multiply together to give 2, numbers that multiply together to give 10. I'll draw my 2 sets of parentheses. So 1x times 2x. And I'm just going to be pairing them. That. Let's see. 2 and 5. Well, I'm going to try it with the 2 and 5 first. Well, I can't put the 2 here because it would be 2 even numbers. Common factors in those parentheses. There shouldn't be any common factors in there. So let's try putting the 2 here and the 5 there. Ooh, weird. 2, 5. Now I want these outer and inner to subtract to get me that middle term. We know there should be 1 plus and 1 minus, but notice I haven't filled it in yet because I'm not sure where the plus goes. Does it go here and the minus here, or the other way around? So let's see if I can make this work. I remember years ago a hostile student saying, "You're just making these things work out." And I was like, yes, exactly. That is a very smart statement. Let's see. Could I subtract the 4 and 5 to get a middle term, 1x? Well, yeah. I think I've already got this one pretty much factored. All I got to do is figure out how should I arrange the plus and the minus. That middle term should be a positive 1x. In order for these to subtract and give me a positive 1, the bigger number here would need to have the plus. The 5 would need to be this plus here, minus there. Negative 4x plus 5x is 1x. In order to get a negative here, I need a minus there and a plus there. You might want to pause the video and FOIL that out and convince yourself that what we have right here is exactly what we have. Or if we FOIL this out, we're going to have exactly what you get right there. Okay? Notice, if you have 1 plus and 1 minus in the factored form, when you look at the outer and inner, and that's what these marks are. First, outer, inner, when you're doing the FOIL, the outer and inner should combine to give you that middle term. Can I subtract the 4 and 5 to get a 1? Well, yeah. Okay, so how do I arrange that plus and minus? And once we have it factored, set each one of these factors to 0. So I'll add 2 to both sides to get x equals 2. With my math lab, you'll be typing in these numbers. 2, comma. And then on this one, you subtract 5 from both sides. And then divide both sides by 2 to get a negative 5 over 2. So we have positive 2 and negative 5 over 2 as our solutions. Now, let's see. I think your homework assignment has 3 of these for you to do. Let's see. Problem number 1. Well, so I'm going to do these first 3 and then we'll take a break here. Well, let's see. This is called a simple trinomial because there's not a number in front of this first term here. So it's going to be easier to factor it. What numbers multiply together to give a 20? Well, 1 times 20, 2 times 10, 4 and 5. I'll draw my 2 sets of parentheses. B times B is B squared. Notice there's no numbers that we got to worry about, so that's going to make it easier. The second sign is plus, so we're going to have 2 of the first sign. We want numbers to multiply together to give a positive, but add together to give a negative. So if the second sign is plus, minus, minus, and let's see. Do you have a feeling for which pair of numbers are going to work? 1 and 20, 2 and 10, 4 and 5? Yep. And you can FOIL that out. You might want to pause it and FOIL it out. You'd have b squared, then a minus 5b and a minus 4b. Don't those add together to give a minus 9b? The negative 4 times negative 5 is positive 20. Set each one of these to 0. Add 4 to both sides. So we get b equal 4. Add 5 to each side. B equals 5. So on my math lab, you'll come up here where it says the solution set is, and you're going to type in 4, comma, 5. When you type this stuff in, never hit a space key with my math lab. Okay? That one's pretty easy. Let's try the next one. If you can muddle through these factoring problems here, then you can factor good enough for the semester. Factoring will be popping up throughout the semester. Let's see, what about this one here? Oh, gee. Well, it's not a simple trinomial because there's a number right here. So we're going to have to say, okay, 1 and 3. Now for 32, well, what are the numbers that multiply together to give 32? Well, there's several of them. 1 times 32, 2 times 16, and another pair, 4 times 8. Now, the second sign is plus, so the factored form should have 2 of the first sign. So I'll start off, well, there's not any possibility other than 1 times 3 to get going. So 1x times 3x, let's say that. And I'll just be pairing it, 4 and 8, 2 and 16, 1 and 32. Oh, let's go ahead and fill in the signs. The second sign is plus, so 2 of the first. So it's just going to be plus and plus. Now here's where the trial and error comes in. As you do more and more of these, you're going to be able to get to the point where you can spot which pair of numbers works a lot faster. Try putting a 4 here and an 8 there. And then you're going to check. Did the outer and inner combine to give you that 22x? Like we'd have a 12x and an 8x? No. Those don't combine. So the 4 and the 8 can't go there like that. So that's not going to work. What I'm about to do is reverse the 4 and 8. Let's reverse the 4 and 8. Put the 8 here and the 4 there. Is that going to work? By work, I mean, will it give us that middle term, the 22x? Well, we'd have a 24x positive and a positive 4x. That would give us a middle term of 28. So it looks like the 4 and 8 don't work. 16 and 2. Let's try that. Okay, so I'm now trying 2 and 16, or 16 times 2. 2 times 16, oh, they're both pluses, right? If I look at outer and inner, is that going to combine to give a 22x? I would have a 6x and a 16x. Both of them are positive, right? Is that giving me a 22x? I'm thinking it is. Put it like this. Ooh. So I'm doing number 2, this one right here. So we now have the 22x. So this is the factored form. So let's set each one of those factors to 0. Set the x plus 2 to 0. And the 3x plus 16, I'll set that to 0. So subtract 2 from both sides. Instead of writing that out like that, what you'll see me doing, my habit is just put the little arrow, meaning move it over and change the sign, which would be subtracting 2. Right here, I would do this. So I'd have 3x equals a negative 16, then divide by 3. So the two numbers that you have to type in are negative 2 and negative 16 over 3. Negative 2, comma, negative 16 over 3. In algebra, usually we use, when we talk about simplified fractions, we mean improper fractions. Okay? Now when you type that stuff in, notice it looks like I left space there. You don't hit space key at any time. It'll space it correctly for you. Okay. One more and then we'll take a break. This number 3. Ooh, it's not written in standard form, is it? You need a 0 on one side. This is number 3. So I need to move that 15 over. Minus 15 equals 0. So here's what I'm going to try to factor. 1 times 4 or 2 times 2 give me the 4. For the 15, there's 1 times 15 or 3 times 5. Well, it's a trial and error process. This is one where the second sign is minus, so that means there's going to be 1 plus and 1 minus. But numbers multiply together to give a negative. Well, a positive times a negative. I'll try the 2v times 2v first. And then I'll try it with the 3 and 5 and the 1 and 15. The 3 and 5. Notice I didn't fill in the plus and minus because I don't know where they go yet. Does the plus go in the first set of parentheses or does it go in the second? $6v and 10v. Can I look back at this table, this third column here? If the second sign is minus, you want that outer and inner to subtract to give you the middle. Do the 6v and 10v subtract to give you a negative 17v? No. So the 3 and 5 aren't going to work, and switching them wouldn't help because it wouldn't change anything since both of these numbers. Putting the 5 there and the 3 there, it's still the same thing you have as right there. So that doesn't work. Let's try 2v times 2v and 1 and 15. Well, I'm thinking this is going to get it too big right off. We would have a 2v and a 30v. Those aren't going to subtract to give me a negative 17v. So that means the 2 and 2 doesn't work. Well, let's try it with 1 and the 4. So that one didn't work. Let's see. V times 4v, and let's try it with 5 times 3. I'm going to look at the outer and in. If this doesn't work, I'll try reversing the 5 and 3. Maybe that'll help them. I'd have a 20v and a 3v. Can I subtract those to get a negative 17v? You bet I can. The bigger product should have this sign here, so a negative there and a plus there, which means there needs to be a minus here and a plus there. You might want to pause this and fill this out to convince yourself I'm getting what I have right there. And once you convince yourself of that, and you move over here. Take each one of these, set them to 0. V minus 5 is 0. 4v plus 3 is 0. So move the 5 over. So 5 is one answer. Then subtract 3. So move the 3 over. And divide by 4. Negative 3 over 4 is the other answer you'll type in. So you'll type in 5, comma, negative 3 over 4. So it just takes a little bit of practice. In Math 371, I remember teaching that years ago, and we'd spend like 6 weeks on this factoring stuff, and here I'm trying to review it in just a few minutes. So it takes some practice, and if you can muddle through these 3 problems here, you can factor good enough, okay? Or if you're still having trouble, you might want to click similar exercise and get these to regenerate so you can practice some more, okay? You can always, once you do a problem, and even if you get it right, you can click similar exercise and just practice some more with it, okay? So we're going to take a break now, and we'll discuss the other 2 methods, the square root property and the quadratic formula, after the break. Okay? Thanks for listening.